Welcome, AI architects. Today, we are mastering a critical component of production-grade AI systems, dynamic breakpoints. We will focus specifically on pausing your agentic graphs for external validation, ensuring your autonomous systems remain safe and controllable. Let's get started. Let's kick things off by defining dynamic breakpoints. As we build highly autonomous agents, we inevitably hit a boundary. Some actions are simply too risky to execute without oversight. Dynamic breakpoints are intentional pauses injected into your agent's workflow. Instead of letting the model hallucinate or execute a destructive action, we halt the graph. Why is this critical? The shared state pattern used in LangGraph makes it easier to observe, interrupt, and modify the application right when it matters most. By freezing the execution, we give a human or an external compliance system the opportunity to review the agent's plan, validate its parameters, and explicitly authorize it to continue. This moves us from hoping it works to guaranteed safety. Look at this flowchart to visualize the fundamental concept. The agent reasoning flows normally until a high-risk action is detected. At this diamond, the flow intercepts and triggers a dynamic breakpoint. The entire state freezes, waiting for external human validation. Once the human reviews the context, they can either approve the action to resume execution or reject it, safely rerouting the workflow. The breakpoint acts as an impenetrable safety net. To pause an AI graph, you first need a flawless memory system. If you stop the execution to wait for a human manager to approve a task, that manager might take 3 hours to reply. Your server shouldn't stay awake waiting. This is where state persistence comes in. To enable breakpoints, you must attach a checkpointer, like memory saver, to your graph. What this does is serialize the entire state, every variable, every message, every tool parameter, and save it securely. When the human finally responds, anytime the graph is called, it starts by using the checkpointer to fetch the most recent save state. The agent wakes up, rehydrates its memory exactly as it left it, and continues. Without persistent checkpoints, dynamic breakpoints simply cannot exist in a stateless architecture. This diagram shows the persistence layer in action. After a node completes during graph execution, the state hits the checkpointer, in this case, memory saver. It serializes the exact state and writes it to a database or local memory. Hours later, when validation is received, the dotted line shows the checkpointer fetching the state, allowing the graph to wake up seamlessly and move to the next node. Why do we actually need external validation? We use what is called the agent calls human pattern. This is a formal escalation mechanism where the agent pauses its workflow, packages all relevant context, and routes it to a human operator. We do this because it ensures that critical decisions are vetted by a human, reducing the risk of costly automated errors. Imagine an agent deciding whether to issue a full refund or send a legally binding email. If the agent's confidence score drops below 95%, or if a strict policy rule is triggered, the agent shouldn't guess. It should raise its hand. By building breakpoints into the architecture, you transform your agent from an unguided missile into a collaborative teammate that knows its own limits. Here is the architectural view of the agent calls human pattern. The agent workflow hits a snag, perhaps confidence is low. This triggers the escalation trigger, which forces a pause. The context is securely shipped to the human review dashboard. The operator reviews the data and approves it, injecting the decision back into the flow, and the agent safely resumes its work. Let's look at the first method for implementing this: static pauses using the interrupt before parameter. This is a configuration setting that halts your graph immediately before a specified node begins. How do you use it? Simply pass interrupt before sad face tools when streaming or invoking your graph. Why is this brilliant? Because it allows you to pause the graph right after the LLM has decided what tool to use, but right before that tool actually runs. The execution yields back to your client app, and you can inspect the exact arguments the LLM generated. If the LLM drafted an email, you can read it, edit it in the state, and then approve it. It provides absolute control over tool execution boundaries. Let's trace this sequence. The app starts the stream, explicitly requesting an interruption before the tool's node. The graph engine runs the LLM node, which decides to call send email. The engine sees the breakpoint and instantly yields control back to the app, pausing execution. The human inspects the state, validates the email text, and issues a resume command. Only then does the tool node execute. While stopping at node boundaries is great, sometimes you need finer control. Enter the dynamic interrupt function. This tool allows you to pause execution dynamically from exactly inside a node's logic. If your agent is processing data and realizes a critical field is missing, it can call interrupt. What is your address? The function returns a special interrupt state and completely stops the server. The beauty of this is its surgical precision. You don't have to wait for a node to finish. You stop right in the middle of the Python code. When the human provides the missing address, the graph reawakens, injecting that exact text into your variable, and the Python function continues executing seamlessly as if it had never stopped. Look at the internal node logic here. Execution starts and hits a conditional check. Is data missing? If yes, it calls the interrupt function. The system yields the special interrupt state and pauses the graph entirely. Later, the human provides the data via a resume command. The framework miraculously injects that exact data back into the paused variable, and the node finishes its execution. Let's look at an incredibly important real-time use case, financial transaction approval. Imagine you have a highly capable AI agent processing wire transfers. A user requests to wire $75,000. The agent flawlessly reads the intent and prepares the API payload. But corporate compliance mandates that any transfer over $50,000 requires human dual authorization. Our system uses the dynamic interrupt function. Inside the processing node, the code detects the $75,000 amount and triggers an interrupt, passing the transaction details as a JSON payload. The graph instantly suspends. An alert pops up on a compliance officer's dashboard. The officer manually verifies the recipient, clicks approve, and the agent awakens to execute the transfer. We have successfully blended AI speed with strict human compliance. This state diagram perfectly illustrates our compliance workflow. The request is parsed, and we check the amount. If it's under $50K, it executes directly. But if it's over $50K, we enter the human approval required state. We call the interrupt, and the graph enters the suspended state. It stays there until the human explicitly sends an approve command to execute or a reject command to cancel. To conclude, how do we actually wake the graph back up? We use the command interface. To resume, you call graph.stream command resume equals user response config. This powerful command takes the human's response, whether it's a simple text string, an approval boolean, or a completely edited JSON payload, and injects it directly back into the pause state. Before you implement this in production, remember 2 golden best practices. First, always implement timeouts. If a human forgets to approve a task, you don't want a dangling graph forever. Route it to a safe cancellation state after 24 hours. Second, ensure your interrupt payload provides rich context so the human operator isn't left guessing. Mastering these breakpoints bridges the gap between chaotic automation and trusted, enterprise-grade AI. To master these patterns and take your AI engineering to the next level, I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Our final diagram shows the resurrection of the graph. The paused graph waits for the human dashboard. The human generates the approval payload. This payload is wrapped in a command object and sent back via graph stream, highlighted in green. The graph awakens, processes the validated payload securely, and proceeds to deliver a safe final output. Thank you for joining this session.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by Quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepared for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.